Hi, my name is Siddra Maryam, and I'm a PhD student at Tyndall National Institute, Cork. And here I'm presenting a poster, Early Stage Diagnosis of Oral Cancer, an Optical Spectroscopic Approach, SERS and SORS. Oral cancer is one of the most common and aggressive oral malignancies in the world. It includes a variety of tumors occurring in head, neck, and oral cavity, including tongue, palate, buccal mucosa, tonsils, and tongue base. Use of tobacco, alcohol, areca nut, betel, mouthwash, and human papillomavirus are the main causing agents for oral cancer. It is the 11th most common cancer in the world. The rate of occurrence and mortality due to oral cancer varies in different regions of the earth. Even in Ireland, according to Irish Cancer Society, more than 700 new cases of oral and pharynx cancer are reported every year. This condition is far more worse in Southeast Asia and Africa. USA, China, India, and Pakistan are topmost countries reporting oral cancer. Despite a slight decrease in occurrence of oral cancer in last few years, cases of tongue cancer are still increasing and survival rate is very low because of the late-stage diagnosis. Between 2015 and 2017, in Ireland, an average of more than 40% of oral cancer patients were diagnosed in fourth stage, compared to 27% of fourth-stage oral cancer patients in 1994 to 2002. When the tumor is in advanced stage, the prognosis and survival rate is very low. Oral cancer is a multi-stage process, and diagnosis in early stage is critical, but it can improve the survival rate and quality of life after the treatment. Currently, the gold standard procedure for diagnosing oral cancer is physical examination, followed by biopsy and histopathological examination. Early stage diagnosis of oral cancer is a complex process due to unspecific development of non-malignant lesions into cancer and impossibility to take biopsy of every lesion. For this purpose, there is a need to develop a non-invasive and painless diagnostic procedure. Optical spectroscopy could play a vital role in this regard as a non-invasive, non-destructive, and molecular sensitive technique. The aim of this study is to validate the performance of different spectroscopic techniques for oral cancer detection in early stages. And upon technology validation, technology transfer, and multi-center clinical trials will be performed in order to translate the optical technology to clinic. This poster, however, will only focus on surface-enhanced Raman spectroscopy and spatially offset Raman spectroscopy. This project is in initial research stage, and experiments will begin after the ethical approval. First step of this project is to perform an ex vivo examination of saliva specimen through surface-enhanced Raman spectroscopy. Why we have chosen this particular technique is because Raman spectroscopy is simple, it is less time-consuming, even a small specimen size could be sufficient, though it is very expensive, but it is highly sensitive. It can even recognize the peaks which are invisible to infrared spectroscopy. And unlike Raman spectroscopy, surface-enhanced Raman spectroscopy has a very strong signal because of surface plasmon resonance produced by nanoparticles deposited on the substrate. The whole procedure involves the collection of saliva specimen from patients and from a group of healthy people. Saliva specimen will then be centrifuged to separate it in spermatant and cell pellet. This specimen could be stored at low temperature. While doing the analysis, the sample will be thawed on the substrate coated with nanoparticles and will be analyzed with a 785 nanometer laser. And then the obtained Raman spectra will be analyzed. This is the Raman spectroscopy that we are planning to use in this study. And this is the schematic of a microscope that we have designed for this ex vivo analysis. The second part of this experiment involves the in vivo analysis of cancerous tissue. For this purpose, of course, we cannot use this microscope. That is why we would like to have an optical fiber probe with this customized tip configuration. It contains the source fiber in the center and has 3 concentric rings of detectors at different radii. So the measurement will be taken at 3 different source to detector distances. The benefit of doing this is that the distance between source and detector, as the distance between source and detector increases, the light will have a chance to penetrate into more deeper layers of the tissue. That is why the most closer ring of the detector will collect the data only from the superficial layer of the tissue. And this is how we are planning to look for the changes in the tissue at the deeper layer as well. As I have already mentioned that this project is still in initial phases and experiment will begin as soon as we'll get the ethical approval. So right now we don't have any results, but here are a few things that we expect to be a potential biomarker for oral cancer. They include protein, DNA, lipid, water, amino acid, and nucleic acid. Thank you very much.